Hi, classmates. We are EST1. We are presenting our behavior change project. It is increasing physical activity for adults during free play. I'm Shelby Barth.
I'm Lori Platt.
I'm Chris Sinclair.
And I'm Fabian Serna. So moving into our original study, it was a Hayes and Van Camp article published in 2015 titled Increasing Physical Activity of Children During School Recess. The purpose of the original study was to evaluate the effects of an intervention package aimed at increasing the physical activity of school-aged children during unstructured recess. The subjects were 6 typically developing 8-year-old girls from a 3rd grade class. And in this article, 4 were deemed healthy, 1 was overweight, and 1 was underweight. The setting was 22 20-minute sessions that were conducted on their elementary school playground during their regular scheduled unstructured recess, where the participants were allowed to engage in any kind of free play with a variety of items that they so choose. In the experiment, what they were measuring was the number of steps or the frequency during these 20-minute sessions via Fitbit accelerometers located on their person, so either in their waist or on their pocket. And the data was collected at the end of each session from the Fitbits by an experimenter. The intervention utilized in this study to increase the number of steps taken was reinforcement and self-management components. These were reinforcement, self-monitoring, goal setting, and feedback. And the design utilized was an AB-AB reversal design. For the procedure, the subjects were equipped with Fitbits and given their intervention-related instructions. So whether they're in baseline or during the intervention, in baseline, the subjects were not given feedback and they were unaware of their step count throughout their session. And then during intervention, subjects were given their session goal. This was calculated by their 4 previous sessions, and then a percentage of number of steps they had to achieve was increased the more they met their goals. And during intervention, they were encouraged to look at their Fitbits and reference their goal throughout the session. This was the self-monitoring component. And then they would complete the 20-minute session and then have their data recorded. And then they would report whether they met their goal or not. At the end of each session, a tangible reinforcer was delivered for meeting their goal, along with verbal praise and words of encouragement if they did not meet their goal. And this was the feedback component of the experiment. So how did it turn out? The results of the experiment are during initial baseline phase, the participants kept their steps below 1,200. And then the initial intervention phase was implemented and all subjects increased their step totals and exceeded their goals. 4 out of 6 subjects actually increased their steps to 40% from their baseline totals. And then once we reversed back to baseline, all subjects decreased their steps with the absence of the intervention. And then in the final phase of the study, they re-implemented the intervention, and 5 out of 6 subjects increased their step total. And then overall, subjects took 47% more steps during intervention phases than baseline phases. Discussion points from this article is that the intervention included reinforcing and self-managing components, and they were successful at increasing the total steps taken, which supported previous literature, which we'll discuss later in this presentation. And some limitations from this study was that there was data loss due to technological error and the feasibility of identified reinforcers and time constraint to complete certain aspects of the study. So moving on to supporting literature. A 2005 article by Kress et al. Stated that scientific evidence indicates that regular physical activity can bring dramatic health benefits to people of all ages and abilities. So this is the big why we are wanting to complete this study and support the previous findings. The article goes on to explain that simply knowing about the importance of physical activity is seldom sufficient to motivate a sedentary individual to initiate and maintain physical activity on a regular basis. So in other words, just having the information out there is not enough to motivate individuals to engage in physical activity. Some of these, or the article suggests that the solution to this problem is to incorporate several well-established principles of behavior change which then can lead to increases in motivation for participating in such exercise programs. So these are things like social support, so telling a friend or having an exercise buddy there to hold you accountable. Number 2 is self-efficacy. So this is just exerting control over your own motivation and behavior, having the belief in yourself that you can engage in these physical activities. The third one would be active choices. So we're more inclined and more motivated to engage in physical activity if we're open to choosing any kind of activity that is tailored to our needs and interests. And in our case, we were able to, one, choose the activity you wanted to engage in, and also the environment in which you wanted to engage with it at. A fourth one would be creating some sort of health contract. Now, usually this is done with a health professional, but in our case, it was more so just creating a measurable plan and having goals that we can meet. So this was increasing our steps from 10%, 20%, and 30% above our baseline rates. A fifth one would be regular performance feedback, and this was just giving positive and meaningful verbal praise in cases where our goals were met, and providing words of encouragement, such as you'll get it next time if goals were not met. The sixth one would be providing positive reinforcement to participants after they met their goals for their sessions. So this is just rewards for, once again, reaching their targeted goals. A 2008 article by Norman also stated that another kind of intervention can be self-monitoring, which has proved to be effective both as a measurement strategy and as a behavior change strategy across a variety of diverse target behaviors. So in this article, self-monitoring procedures were successfully employed in a number of behavioral interventions targeting increases in physical activity, and was a part of a multi-component intervention. Some other articles that we have to support the literature regarding these interventions and increasing physical activity was Wyatt et al. In 2004, and they used the electronic step counters to increase physical activity. And the overall finding of this article was that inexpensive step counters provide accurate measurements of steps. They require little to no effort and provide participants with immediate and accurate feedback, suggesting that these may serve as a motivating factor when trying to increase the number of steps taken per day or in a given session. In Norman's 2008 article, interventions of goal setting, self-monitoring, and feedback intervention were used to increase the number of steps. And all participants in this study reported that they believed the self-monitoring and feedback helped them to take more steps each day, and that the intervention was successful. These results also suggest that low-cost and unobtrusive intervention can be used to increase the physical activity of healthy adults. And then in our Galbraith and Norman 2017 study, this was able to show that these results can be generalized to other populations. And so this was used with elementary age students, in which positive reinforcement interventions were implemented. And this was in the form of a badge and a token economy system. And this study found that compared to baseline, students' step counts increased during the intervention phases. The only limitation to this study was that they did not necessarily define what physical activity was, which jeopardized their treatment fidelity. And then our final article, Morris et al. 2019, it was also performed on elementary age children, aimed at reducing their sedentary time during the school hours. The intervention used here was incorporated within a learning activity, reducing their amount of sedentary time while continuing learning. So physical activity was measured with pedometers, once again, with recording the numbers of steps taken per day. And the children were actually able to set their own goals and then graph it within their classroom if those goals were met. So moving on to our purpose of our study.
So the purpose of the current study was to evaluate if the use of two behavioral interventions, being contingency management and self-management, would aid in increasing the number of steps a group of adults take during individual, unstructured physical activity time. So when we say contingency management, we mean if the goals are met, the subjects will earn access to a previously identified preferred item or activity. And when we say self-management, we mean the subjects will be able to monitor their own progress throughout the sessions. So For the participants for this study were recruited from the 814 section of a SPCE 611 graduate level course from Ball State University. And they consisted of 4 adults ages 24 to 40 years old, 2 women and 2 men. 2 were considered healthy and 2 were considered overweight according to the BMI calculator. And the current study consisted of 22 20-minute physical activity free play sessions. And the sessions were conducted in open space locations, a gym, a fitness center, parks, walking tracks, or trails. Now, the participants in this study were not restricted in the selection of their preferred physical activity, so that's what we mean when we say free play. Okay, so materials utilized for this study. A cell phone equipped with 2 downloaded step tracking applications. One was called Steps app and the other was called Pacer. The Steps app was our primary data collection software and Pacer was the secondary data collection software. Another material utilized was the previously identified potential reinforcers. So the reinforcers were identified through an interverbal preference assessment. So asking the participants what they would be motivated, what would motivate them to earn, asking participants what they would be motivated to earn for reaching goals during the study. And so the reinforcers that the participants identified were a hot bath, television, or a computer or laptop access for watching a preferred show, a strawberry Starbucks refresher, or 30 minutes of reading a preferred book. So these reinforcers were delivered immediately after the session if the participants met their session goals. So the next material utilized was a free space area to conduct the physical activity sessions. So the free space areas included, again, parks, gym or fitness centers, and walking tracks or trails. Another material utilized was a computer or device equipped with Microsoft Excel. And so the computer or device was utilized to collect and graph data throughout the duration of this study. So moving on to the target behavior and a definition. So our target behavior was step. And the operational definition of a step is any occurrence of raising one's foot and then reapplying it to a surface. So some examples would be running or walking, playing a game of sports, basketball, football, etc., jumping or skipping, climbing stairs, using a stair climbing or elliptical machine, and walking or jogging in place. Some non-examples include tapping your foot, sitting on a playground, swinging on a swing, lifting weights, stretching, or riding a stationary bicycle.
So data collection. Data collection utilized in our study, we use event recording and in the form of frequency, the count of steps taken during the 20-minute activity sessions. The frequency dimension was chosen as this study required every step or every instance of our behavior to be tracked to determine a final count after each session. The data was collected on both the primary and secondary step tracking applications on the participants' mobile devices. And you'll later find out within the treatment fidelity, screenshots of both apps were taken before having our smaller count, and then after, which was our larger count. Then to calculate our total, we took the larger count, subtracted the smaller count, giving us that total step count during our 20-minute session. And then after the sessions were completed, this data was then transferred to a Google document and graphed, so that way we can monitor progress throughout our own individual studies. The treatment design utilized in our experiment is based off the one utilized in the original study, which was an AB design or withdrawal design. Our first intervention was the baseline, so collecting our initial sessions, and then we moved into intervention phase 1, returned back to baseline, and then re-implemented the intervention for our final phase of the study. Data was collected and monitored, graphed, and visually analyzed to ensure proper transitional timing between phases. And then the baseline phases required a stable or non-ascending data trend path to ensure a functional relationship was established due to the intervention, and then not any other variables. So when we say this, we mean that the steps are increasing due to the intervention, and we're not already increasing before the intervention was even implemented. And then in order to transition back to baseline, which was our third phase of the study, the data path of the intervention phase required demonstration of an ascending data trend to exhibit that the steps were actually increasing due to the intervention being in place.
So for the baseline phase, we had 2 phases, which was the A phase of our design. The baseline data sessions were conducted in several environments by participating in a variety of free play activities. Some examples of the activities were walking, jogging around our neighborhood, walking or jogging on a treadmill in an individual's home, walking around the city, walking around an individual's home, and other activities that are similar in nature. During the baseline phase, the participants had no set goals or expectations, and they were not allowed to reference their current step count as their session was ongoing. As well as that, no feedback was given by the group members, and no reinforcement was delivered when the sessions were completed. For the treatment phase, participants were given step goals that rose in increments of 10%, and then eventually 20%. And if they did hit their step goals for 2 consecutive sessions, that is when it would increase. The step goal was calculated by averaging the previous 4 sessions and then raising that number by 10%. As stated previously, when that 10% goal was accomplished for 2 consecutive sessions, the goal was then raised to 20%. And then if that 20% goal was reached 2 consecutive sessions, then it was raised to a 30%. Participants were encouraged to reference their current step goal throughout the treatment phase, their previous step totals, and the current amount of steps on their trackers during their sessions to help motivate themselves. After the session was concluded, participants sent a message to the other group members stating whether or not they had met their step goal. If the participant had met their step goal, the other group members would encourage or would praise the individual by sending messages such as "great job," "you did it." If the participant did not meet their step goal, messages encouraging the individual were sent to them, such as "you'll get it next time," "you got this," etc. Before the study had officially started, as we stated previously, there was a preference assessment that was created for the participants. This determined what reinforcer would be given to each participant if they met their goals during the treatment phase. The preference assessment identified reinforcers that each individual had deemed would be an effective reinforcer for themselves. The participants were given 5 age-appropriate and relatively inexpensive options to reinforce them that they could choose from. The options presented in the preference assessment included a hot bath, Starbucks coffee or a drink, 30 minutes of reading, and 1 episode of a TV show. And this is just an example of the preference assessment. So we had it set up like this, a table with our names and our options of reinforcement, and we each went through and selected which option would be the most reinforcing to us personally.
So inter-observer agreement data was recorded during every 3rd session throughout the study. The participants utilized the screenshot feature of their smartphones to record the number of steps taken just before starting the session. And then they would do the same after the session ended. So they would take a screenshot then of the number immediately after the session ended to find out their total steps taken during the session. Each participant was assigned a reliability partner who would then use total count IOA to compute the IOA percentage based on the session screenshot that were sent to them. The total count IOA was calculated by using the formula smaller count divided by larger count times 100. And the participant and the reliability partner then compared their results. So this was our IOA data sharing procedure. We added daily screenshots to a shared Google Drive folder, and all members of the team had access to the folders. So the IOA partners were able to perform the inter-observer agreement by calculating step totals of their partner via their uploaded screenshots, as you can see demonstrated here.
For our treatment fidelity, it was monitored by adhering to a treatment fidelity checklist that we created, and the participants calculated their own treatment fidelity for each session using the checklist as their guide. There were two separate treatment fidelity checklists, one for baseline and one for the treatment phase. For the baseline treatment fidelity checklist, prior to the start of the session, we would go through and do these steps, which were open Steps app and Pacer apps at the start of the session and take screenshots of steps taken for the day, set a phone timer for 20 minutes, place phone in pocket, engage in free play for 20 minutes, open Steps and Pacer apps immediately at the end of the 20-minute session and take screenshots of the steps taken that day, then subtract steps prior to session from steps taken after the session, and then record the data on our Google Docs spreadsheet. For the treatment fidelity checklist for the treatment phase, we would record step goals for the 4 previous sessions, calculate our step goal, which was the average of 4 previous sessions, plus 10%, 20%, 30%, or 40%, depending on where we were in the treatment. We would write our step goal on a piece of paper, open and take screenshots of the Steps and Pacer apps, set a phone timer for 20 minutes, keep our app open so that we could view and reference our step count, engage in our free play session for 20 minutes, frequently view the step count in Steps and Pacer apps, halt play when the 20 minutes is up, take a screenshot of our Steps and Pacer apps, and then calculate the totals for each app, record our data, then message our group members what our step total was in our Google Hangouts chat, and then receive praise for a goal reached and encouragement for goal not reached. And then finally, gain access to our reinforcer of choice for meeting our goal if we met our goal. This is an example of our baseline treatment fidelity checklist. As you can see, there were 2 columns where we would check off yes or no if we met that criteria. And here is our treatment checklist right here. And some of the common ones that would affect our treatment fidelity would be, for example, forgetting to take a screenshot at the beginning or end of a session, or forgetting to set a phone timer, or forgetting to receive praise if we met a goal, or encouragement if we did not meet a goal. For reliability, every participant collected data from our primary step tracking application, which was Steps app, and a secondary step tracking application, which was Pacer. And Pacer was utilized to gather our reliability data. The participants gathered the step data prior to beginning each session and also the data immediately after concluding the session. They then subtracted the beginning total steps from the total steps at the end of the session to determine the amount of steps taken during that 20-minute free play session. To obtain a reliability percentage for the session, the participants used the formula smaller total number of steps during the session divided by the larger total number of steps during the session multiplied by 100. An example of that would be For example, if our Pacer app showed 2,500 steps and our Steps app showed 2,400 steps, we would then divide the 2,400 by the 2,500 and multiply by 100 to gain that percentage. On this table, we have our total percentages throughout the entire study replication for our reliability and our treatment fidelity. And as you can see, all participants maintained a relatively high reliability percentage and treatment fidelity percentage. Chris, myself, maintained a 99.7 reliability percentage. Shelby also had a 99.7 reliability percentage between the apps. Lori had a 99.27% reliability percentage, and Fabian had a 100% reliability percentage. So all participants were over 99%. For the treatment fidelity percentage, myself, Chris, I had a 99.55% total percentage. Shelby had a 97%. Lori had a 98.9%, and Fabian had a 94.5%. So all participants were over a 94.5% in the treatment fidelity category.
That brings us to the results of our study. So total step data for all participants is shown on the slide following the slide, and we'll show that in just a minute. We all had similar patterns of data. We had increases from baseline to treatment. I had an increase from baseline to treatment of 59.7%. Chris increased 25%. Fabian increased 17.1%, and Lori increased 13.2%. There's a little bit of variation in these percent increases, and we think that it could be due to reactivity. Some of our participants had very high levels of step counts, even in baseline, so their increase of percentage was a little bit lower. So if we'll go to the next slide. I'm sorry, I click out of that. So if we do a little visual analysis of this graph, I know that it's hard to see. I have it zoomed on the next slide, but I want to stay right here so that you can compare all participants. If you'll see in baseline, all participants either started out with stable data or a decreasing counter-therapeutic trend. Then when we move on to the treatment phase, we all see an increase in step count. Then in the reversal back to baseline, we have stable lower levels of step counts, and then a repeat of effect when we return to the treatment. So if we'll go to the next slide. Here you can see zoomed a little bit closer, if that's helpful. Here's a table showing our results. We've included averages and ranges for all treatments. We encountered quite a few limitations when it came to our study. The first of those was uncontrolled motivating reinforcers. And when I say that, I mean that we had a few reinforcers that we were not able to control for during the study. So due to the nature of the project, subjects were subconsciously felt motivated to produce results that matched the original study. So we were inherently trying to make sure that our steps were appropriate in baseline and during the intervention phase. And this could have been another case of reactivity. Variability in step count applications. So between the two apps that we used on our phones, sometimes the phones could have been functioning poorly, or the apps counted steps differently. We found that sometimes even if you just took a few moments too long to take a screenshot, your phone could count additional steps. The next limitation was availability and inconsistency of a free play environment. So because all participants are in different locations, we all experience different weather, different times of day when we could access free play, and because of that, conditions were different. So what may have been an ideal day to do your session for one participant wasn't an ideal day for another participant. Lifestyle variables. This is similar to the last limitation. Due to unforeseen setting events, sessions couldn't always be conducted on the same days. Examples of these were work schedules, illnesses, parenting obligations, and these created a need for flexibility in session schedule. So instead of carrying out sessions on specific days, we made sure that we carried out the same number of sessions. Time is the next limitation. More data points could have been beneficial in showing repeat effects. Specifically for my data, when I returned to my second intervention, I was only able to complete 3 data points before we needed to conclude our project, and a couple more data points would have been more convincing to show effect. The availability of immediate reinforcement was not always available. So ideally, reinforcement is delivered right after the intervention and the completion of the session. But this wasn't always available for a couple of reasons. The first of those being we utilized verbal praise to cheer on our teammates, and we did that via text. And because of the way text messaging works in different time zones, we weren't always able to respond to each other immediately. So that verbal affirmation wasn't always received immediately following your completed goal. Additionally, some of the reinforcers that we chose as appropriate reinforcers for our age division weren't always available immediately following a session. For example, if I went for a walk in the city, I wasn't immediately able to jump in a hot bath, unfortunately. So the next limitation is max performance capacity. What I mean by that is that some members of the group were only able to reach a certain number of steps. An example is that during the sessions, I needed to wear my baby in a carrier on me, and so I was unable to do anything other than walk during the session because a jog may have sent her flying. Limited resources is our final limitation. The original study used Fitbits to count the steps. No members of our group used Fitbits. We didn't have access to them. The original study calculated MVPA, which is the exact number of steps that you're taking in a minute. So we were not able to collect that data. So our final conclusions of the study, as shown in the visual analysis of all participants, reinforcement, self-monitoring, goal setting, and feedback were all effective treatments in increasing physical activity for adults during free play. Our study extends previous literature with clear, objective, observable definition of physical activity. Although we are able to show effective intervention, additional study could be conducted. Although treatment fidelity scores were high, calculations could be misleading. Percent accuracy was calculated against a reference checklist, but not all checklist items carried the same weight of importance. For example, a participant could have free played for 45 minutes rather than 20 minutes. This mix-up would result in only one demerit from the checklist. It would still provide a high fidelity score when in reality treatment procedures were vastly inconsistent. We were unable to control for many confounding variables such as weather, time availability, setting, and data collection. A more controlled environment would lead to a higher treatment fidelity and more reliable results. Finally, additional studies should be conducted on the effects of contingency management and self-management for young adults on physical activity. And that concludes. Here is a list of our references. And that concludes our study.